Examples of differential equations, okay, will be what we have here, which is y. So you can see that we have y squared minus the derivative of y with respect to x, okay, and this multiplied by some x. So we have the function square here, which is y squared, and then we have the derivative of y itself. Okay, so a combination of y with its derivative, okay, written as an equation gives us a differential what? Equation. Okay, good. Again, we have another equation here, which is the derivative y, the function y. This is y squared. Okay, and then we have this the second derivative of y, okay, times y times x, okay, also gives us another differential equation. In the same way, here we have the third derivative combined with the first derivative, okay, giving us another kind of differential equation. So all of these are differential equations. Now, the next thing we need to understand is the order of the differential equation. When we talk about the order of a differential equation, that would mean is given by the highest derivative involved. Okay, so in this equation, the highest derivative involved here is the first derivative. Okay, good. But when we come here, the highest derivative is the second derivative because we have the squared y, the x squared. Okay, and then when we come here, the order of the differential equation is what? The cube y, the x squared. So we have 3. Okay, so this is of order 1 or first order. This is of the second order, and then this equation is of the third order. Now moving on. We want to look at I think I've explained this by how we form differential equations. So let's just skip and go straight to the point. Now, we have different ways of solving differential equations, okay? And one approach, or some of the approaches we'll be looking at in class, will be the direct method, okay? The direct method of integration. We'll be looking at separation of variables, okay? We'll also look at the integration factor approach, and then for homogeneous solutions, which will use substitution, okay, approach. Good. Now we are saying that solving differential equations is a reverse process to the initial process we just looked at. So we said to get the differential equation or the differential equation itself is obtained by differentiating a certain function and then combine it. So if we want to find the solution is the original function. So in the case, let's say we'll be given the s, the t, okay, minus 2s is equals to 0. And you are asked to find the solution to this differential equation. The solution to this differential equation is just to find the function s itself. That is what will be. So in so doing, what you do is you have to do a change of subject, which will bring us to the s, the t is equal to what? Is equal to 2s. That is taking or making this a subject, okay, sending it to the right hand, okay? So you get positive 2s. Then divide both sides by what? S. You divide here by s. And then you multiply both sides by dt. Multiply this side too by dt. Good. This will cancel out that, and then dt cancels out this. So that will give us the expression. That should give us the expression the s, okay, over s is equals to 2 dt. Okay, good. And to solve for such a process, we can use what we call as the direct way, okay? And that is easily obtained by finding the integration of both sides. When we integrate both sides, okay, that should help us to get the function, which is going to be what? Ln of s, okay, which is equals to 2t, okay, plus some unknown constants, okay. Then from there, you can find your s also by finding what the exponent of both sides, which will give us s equals to what? E raised to the power what? 2t, okay, plus c, which is the unknown constant, okay, as the exponent. So that is how you can get the actual function, okay, from the derivative function using the direct approach. Now, moving on, I think I saw a hand up, but it's down again. So let's move on. Yeah, so by the direct approach, okay, we are saying that if a differential equation can be solved can be arranged in the form dy dx, okay, is equals to f of s, can be rearranged, then the solution can be found by direct what? Integration, okay, good. Someone keeps raising the hand and putting it back down. I'll appreciate if you keep your hand on. Okay, so let's move on. So we are saying that if we can rearrange the differential equation in this form, where we have the derivative of y on one side and a function of x on the other side, then we can just integrate both sides, okay? You find the integral here, find the integral here, and you are good to go. So that is what it's saying here. So if you integrate both sides, and then you're going to get this, okay? Good. Technically, what happens is, let me write this well. So what happens is this becomes, by multiplying both sides by dx, this becomes dy, okay, is equals to what? F of x dx, okay, good. And then we bring the integral, you bring the integral. We all know that the integral is the reverse of differential, the derivative, okay, good. So this gives us y, and this will give us the integral of f of x dx. Good. So that is how we come about this operation here, good, which we're going to employ. So let's take an example. So in our example here, we have this example. We've been told to differential equation is giving us dy dx is equals to what? This, and we are supposed to find the solution, which is y. The solution, which is y. How do you get a solution? This is of the form dy dx, okay, equals to what? F of x. This is a function of x, okay, good. So if that is the case, then we just apply the rule, which says that y should be equal to the integral of f of x. So that will be 3x squared, okay, minus 6x plus 5, okay, times dx. Good. And once we integrate that, okay, you're going to get 3x. Integration means you add to the power and divide by the corresponding power. Okay, minus 6x raised to the power, you add 1 to the power. So this will be 2 and divide through by 2. Okay, then the next one will be what? 5x. 5x, then you add a constant of integration, which is what? C. Okay, so yeah, so this will give us x cubed minus 3x squared plus 5x plus what? Plus C. Okay. Yeah, so if there are any questions you can ask before I move on. Are there any questions? Any questions, class? Okay, so let's move on if there are none. Good. We want to try. So try this for me if you don't have any questions. Assuming we have dy dx, okay, is equals to 5x squared plus 3. Okay, find the solution, which is y for me. Find the solution for me. Okay, so in solving this, like we said, just rearrange it in that functional. It's in the form, this is f of x. So let's multiply through by the x and then integrate. So we are going to integrate this 5x squared plus 3, okay, with respect to what? Dx. And then when we integrate this side, we get y is equal to, the integral here will give us what? When you integrate x squared, you get x cubed over 3. So you add 1 to the exponent and divide through by the result plus 3x plus a constant, which is what? Which is C. Okay. So that should give us a solution for this differential equation. So in other words, what we mean is if we should combine, okay, or better still, this solution satisfies the differential equation that we have up there. Okay. So when we find the derivative, we should get back the original derivative equation. Yes, Isaac.
Sir,
Yeah. Having looked at the direct approach, we want to look at the next method, which is separation of variables. Okay. So a typical example of a separation by variable is the one we started with. So assuming we have ds dt, ds dt, okay, let's say minus 2y, if you remember this example initially. We are saying that in this kind of example, this is not of the form, let's assume we take this to this side, okay? We'll have ds dt, okay, is equal to what? 2y. But you see, this is not an f of x, or let's say f of t. This is not an f of t. In the first equation, you said you have dy dx is equal to f of x. So in this case, it should have been ds dt is equals to f of t. But this is not a function of t. This is a function of y. Okay, so what do? We are saying that, but we can still change it to this form by dividing, okay, by dividing through by y. So if you divide here by y and you divide here too by y, this y will cancel out, okay? So it means that, oh, pardon me. The function is a display, it was a function of displacement and velocity. So this should have been s, pardon me, this is s, okay? Yeah, so we divide through by s here and then divide through by s over here, okay? This cancels out and we are left with a function in terms of x, s on the left side, and then a function in terms of t. This is a constant, okay? So it doesn't depend on what? On s, right? Good. So we are saying that if we're able to achieve that, then we can make use of integration to still find what? The solution, okay? So by manipulation, we are saying that if you can send f of, if the right side is a function of y, and you can send f of y to the right side and send the dx to this side, so that the terms on the right side will only have x in them, while the terms on the left side will only have y in them, then we can still apply our integration so easily, okay, and find a solution for y. Good. Now let's take an example to demonstrate. Good. So we have a typical example here. We have dy ds is 2x over y plus 1. Okay, now, like we are saying, this is a function of x. This is a function of x. This is a function of y. You see, this is a function of y. Good. Yes. So what we need to do is we want all the terms on the left to be in terms of y, whilst the ones on the right will be in terms of x. Okay. So by manipulation, if we multiply both sides by what? Y plus 1. Okay. So you multiply this side by y plus 1. And then this side by y plus 1. Okay. This y plus 1 should cancel out this. And then we are left with y plus 1 dy. Okay. Once again, you divide through by what? Dx. Okay. So here we multiply through by dx. And then multiply this side by dx. Dx cancels out dx. And we'll be left with what? 2x dx on the right side. So we have this. Good. So we can clearly see that this function is only made up of what? Y. It's a function of y. And then this side is a function of what? X. Okay. So we have function of x here. And then we have a function of what? Of y on the left side. Okay, good. So which is good. So then we can apply integration to both sides. You find the integral here, you find the integral here. And when we integrate the right side, okay, you integrate y with respect to what? Y. You get y squared. Then integrate 1 with respect to y, you get y. Then you add a constant of integration. Then the same thing when you come to the left side, when you integrate x, you get s squared over 2. Okay, so you get 2s squared over 2. The 2 will cancel out the 2, so you'll be left with s squared here. Then plus the constant of integration, which will be another constant c2. Okay, so we can rearrange, and then we will get the equation by taking this to this side. That will be c2 plus, or c2 minus c1. Okay, c2, a constant minus a constant will still be a constant. Okay, so something like 3 minus 2 will give you 1. 1 is also a constant, so you just keep it as well, a constant. So that is the final solution to this system. Oh, sorry, to this equation. Yeah. Any question? Yes, Isaac.
Yeah, please take it over again, please.
Speech. Yeah, so let me take another example and let's solve. Okay, so let's say we have dy dx. Okay, say plus 3x is equals to 2. And we asked to find a solution. This will give us, we said we want to rearrange so that we have only y terms. Or yeah, better still, let me put some y somewhere to make it more interesting. Okay. Just a minute. So this should give us y here. So to make it more interesting. So y is equals to 0. So what do? We want to have a function of y on the left, okay, and then a function of x on the right, so we can apply, okay, the integral. So what do? This has to go this way. Once we do that, we get dy dx is equal to minus 3y. Then what's next? We want y to go away to the left. Okay, so we divide both sides by y. Divide this side by y. So this y cancels out this y. Okay, and we have 1 over y dy over dx, which is equals to minus 3. Then what's next? We have dx here, right? So multiply both sides by dx. Multiply this side by dx. This will cancel out this. And then you have what? Dy over y is equals to what? equals to minus 3 dx. So what next? We apply this is a function of y. Okay, this is also a function of x. So what do? We apply the integration. So we integrate this side. So we integrate this side and then integrate this side. Okay. Now when we integrate this side, this should give us on the right side. Okay, you are going to get what? Lane of y. Okay, plus a certain constant, let's say c1. Okay, is equals to minus 3 x plus a certain constant, which is what? C. Okay, then you have lane y is equal to 3x, okay, plus this is, let me make it c2, so c2 minus c1. But like I said, a constant minus a constant will still give you a constant. Okay, so this should give us lane y is equal to negative 3x, okay, plus a constant c. Now we want the function y, so you find what? The exponent of both sides. Good. So this is going to give us y is equal to what? E raised to the power minus 3x plus a constant c. Okay, good. Which is the same as e raised to the power c by indices times what? E raised to the power minus 3x. Okay, good. And if you like, e raised to the power constant is also a constant. Okay, so it means that our final solution can be written, I'm writing it up here, so that can be written as what? That can be written as y is equals to a constant times what? E raised to the power minus 3x. So that becomes the solution to the given differential equation. Yeah, are we okay? Yeah, class, are we okay? Are we all okay? If you're okay, just give me okay, or you can ask your questions. Okay, good. Yeah, very well. So having done that, let me give you one to also try your hands on. So you are going to try, let's say we have, let's have, this time we're going to have 2. Okay, then let me have 5 here. Okay, so solve this example for me. We want the solution y to the problem. Solve that for me. So then I'll give you another one, okay, as an assignment. Cool. So let's say we have this equal to um, y plus, okay, 5. So let's make it 2x over y plus 5, okay? So we'll make use of the same technique to solve for it. Now let's look at a solution for the try question I just gave you. So we'll just take this to this side. That should give us 2y dy dx, okay, is equal to what? Minus 5y. Divide both side by y, okay, this side by y, okay, and then both side by 2 again. Divide this side by 2, and then this side by what? 2, right? So the 2 cancels out 2, y cancels out y, okay, and when you're done, you multiply this side by dx, and then this side by dx. This cancels out that, and then we are left with what? Dy over y is equal to what? Minus 5 dx over what? Over 2. Okay, good. So we have the function in terms of y and then in terms of what? X. Okay, good. So we integrate both sides. When we integrate, this should give us ln of y plus a constant c. And when we integrate the other side, we get negative 5. Let's say c1, negative 5 over 2x plus what? Plus c2. Okay. So making y the subject, we have ln y is equal to what? 5 over 2x, okay, plus, of course, when this goes there, subtract from c2, we still get a constant c, okay, good. Then the next thing is you find the exponent of both sides. This should be ln of what? Ln of y is equal to what? E raised to the power minus 5 over 2 x plus c, okay, good. And once again, by indices, we should have, this gives us y is equal to what? Is equal to e raised to the power c times e raised to the power minus 5 over 2, okay, x. And e raised to the power constant is still a constant, okay, good. So we can say maybe c3 or just a constant. Is times e raised to the power minus 5 over 2, okay, x. So this is our y. Y is equal to a constant times e raised to the power minus 5 over 2 x, okay, as your solution. Very good. I'm sure that is what most of us also got at our end. Good. Now moving on from method of separation, we also have the method of, okay, we also have the homogeneous approach and the I'll look at the integration factor approach first, okay, which I need you to be very constant with. So we are saying that if we have functions like this, of this form, okay, so anytime we have a function of this form, then we can go ahead. So what do we mean by a function of this form? So let's say we have dy dx, okay, is equals to say, sorry, say plus 2y, okay, is equals to 3x, okay. When we have it of this form, then it means that this time around we have a q, okay, being 3x here. Good. And then we have y with a function also like this, right? Then what we'll do is this becomes our p. So this is the p, this is the q, okay, good. Now, and we call this factor, this formula, which is the integration factor, okay, if. We call the integration factor if as e raised to the power the integral of p dx. Okay, good. So in this scenario, is if, which is the integration factor, okay, will be e raised to the power integral of p is 2, so 2 dx. So 2 dx, when we integrate 2 with respect to x, what do you get? You get 2x. So your integration factor is what? Is e raised to the power 2x. Okay. Now, after you've obtained your integration factor, what's next? What you do next is you come and multiply the original equation with the integration factor. So you multiply both right side and left side with the integration factor. So when we do that, this is how it will look. It will look like this: 2x, okay, times dy dx, okay, plus 2y equal to 3x times what? E raised to the power 2x. Okay, good. That is how it will look. Then the question is, from here, what's next? Okay, good. Now we'll look at that part with another example. Okay, so let's go on to the sample. That will be this example here. So we have this example is of the form dy dx plus what? Py, okay, is equals to what? Qx, right? Good. So how do we find it? We said first look for your if, the integration factor. The integration factor is e raised to the power what? E raised to the power the integral of p dx. Now your p in this equation here is what? 5. So you have e raised to the power integral of what? 5 dx. Okay, good. And when we integrate 5, you get 5x. Okay, so that will give us e raised to the power 5x. Okay, here you don't bring the constant at the top here. Okay, you don't bring the constant of integration. So e raised to the power 5x. This is your integration factor. Then, like we said, the next stage is to multiply through the equation with what? E raised to the power 5x. So you can see that is what is happening here. So e raised to the power 5x dy dx, e raised to the power 5x times 5y. Then e raised to the power 5x times e raised to the power 2. Okay. Now, whenever you do that, this right-hand side can be proved to be, it always simplifies to the variable, okay? The variable which you are working with, which is y times the integration factor. So we'll not prove that, but that always will simplify into what? The variable we are working with is y, and the integration factor is e raised to the power 5x, okay? So that will be the derivative of y times e raised to the power x dx, okay? Now, if you want us to prove, we'll do that, but this is a very simplified version of that, and you can use the product rule to expand this. Once you do that, you will come back to this form here, right? Good. But first, let's solve it. Then when we are done, we can probably look at the expansion. So this gives us e on the right side. You have e raised to the power 5x times e raised to the power 2x. Okay. Per indices, you add the exponents. So 5x plus 2x will give us what? 7x. Good. So what's next? Now, if you look at it carefully, we still have x here, a function of x here, okay? And we also have the x here. So we want to do a change of something. We want to separate them so we can have function in terms of y only on the right side, and a function in terms of how do we call it, x on the right side, okay? But let's not forget this is in the derivative, okay? So you just can't move it out like that. So what we can move will be the dx. So what we write is we'll have dy, okay, e raised to the power 5x is equals to e raised to the power 7x, okay, dx. So this is the best we can do. Then from here, what next? We integrate both sides, okay? And we are going to integrate this side with respect to y, and integrate this side with respect to x, okay? Good. So when we do that, here, integral cancels out the derivative, okay? So we'll have y times e raised to the power 5x. Then on the right side, when we integrate e raised to the power 7x, okay, from your derivative class, we should have what? E raised to the power 7x, okay, divided by 7, okay, plus a certain constant c. Okay, so you take note of that. Good. So anytime you integrate e raised to the power ax, you get what? E raised to the power ax divided by a. Take note of that. Good. So what I'm saying is a slight correction here. This should be over 7. Good. Then what's next? We want y, okay? So if we want y, we are going to have y is equals to 1, meaning you divide both sides by, you let me do that step. I don't want to skip it. So we are going to divide both sides of the equation. So that will be 1 over e raised to the power 5x, okay, times e raised to the power 5x here, okay, equals to 1 over e raised to the power 5x times e raised to the power 7x over 7, okay, plus c. So this will cancel out this, right? Good. And We will need more space for this. So it means we have on the left side, we have y. And then on the right side, this will give us e raised to the power 2x. Okay, 2x in the sense that from indices, we have 7x minus 5x because they are the same base. Plus this is e raised to the power minus 5x. Okay, c. All right, good. So this will still give us e raised to the power what? 2x, okay, plus c times e raised to the power what? Minus 5x. So y becomes e raised to the power 2x plus c times e raised to the power minus 5 as the final solution. Okay, so Debbie. Yeah, Debbie, let me take your question.
Okay.
Yeah,
Please, the 7. You
yeah.
see, it was divided by some 7. So in the final answer, the 7 doesn't appear there.
Okay, so let me just refresh your memories on when you differentiate the function. First, let me write a function. When you're giving y is equals to e raised to the power ax, okay, the derivative of y with respect to x will give you a times e raised to the power ax. Okay, that is the rule for differentiation. Okay, now for integration, when you are integrating, when you are integrating the same function, it's going to be e ax divided by a. Okay, good. So whereas differentiation will be multiplied by the constant, differentiation will be divided by the constant. Here you don't add 1 to the exponent. You only divide by the constant. Okay, good. I hope I've addressed your question for you, Debbie. Okay. Any other question? Yes, and I think there's something missing here. There should be a 7 here. Maybe that's what Debbie was talking about. So you have to bring the 7 here. Okay, and then this over 7 also here. Okay, so take note of that correction on the slide. I'll correct it before I send it to you anyway. Very well. So this is for example 1. Now let's take another example and solve. So let's try another example. This time we'll go to a whiteboard. So let's say we have the differential equation dy dx minus say 3y or even 3xy. Let's make it our 3xy is equals to say 2. Okay, is equal to say 2. Good. So how do we solve this problem? First, this is px, or this is p, okay, right, and then this is q. Good. So we first look for our if, which is the integration factor. The integration factor is e raised to the power integral of p, okay, dx. So that will be equal to e raised to the power the integral of p is 3x, so 3x dx. Now when we integrate 3x, we'll get 3x squared over 2. Okay, once again, you don't introduce the constant of integration, so that will give us the final result to be so our final result is this. Good. So what next? So we'll multiply both sides by, yes, Ibrahim.
Please, then it's negative 3x. You didn't bring the negative sign.
Yes, thank you, Ibrahim. Minus. Thank you. Okay. Because there is a negative here, it's not a plus. Okay. Good. Yeah, so we'll multiply both sides of the equation by this. Okay, good. So which means that we have e raised to the power minus 3x squared over 2, okay, times whatever is on the left side, which is dy dx here, okay, minus 3x y equal to 2 times e raised to the power minus what? Minus 3x squared over 2. So once we do that, like I said, this side will always collapse to derivative of the variable which we are working with, which will be y, and the integration factor, which will be e raised to the power minus 3x squared over 2. Okay, good, with respect to dx. And then the right side will be 2e raised to the power minus 3x squared over 2. Good. So what next? We just multiply both sides by dx. Okay, so we can do the integration.